differential equations of first order and first degree. Differential equations means an equation in which derivatives are involved. For the first order means the highest order derivative in given equation should be dy by dx. And first degree means its power or exponent, that is power of dy by dx should be 1. Such type of equations are said to be differential equations of first order and first degree. First order and first degree differential equation basically can be expressed in these two standard form. First standard form is dy by dx is equal to f of x comma y, and second form is m dx plus n dy is equal to 0, where both m and n are functions of x and y. Suppose if we consider the second standard form, that is m dx plus n dy is equal to 0, and rewriting it, we can write this equation as dy by dx is equal to minus m times x comma y divided by n times x comma y. It means the whole expression of right hand side is actually a function of x comma y, so it can be expressed as the function of x comma y. Therefore, this second standard form m dx plus n dy is equal to 0 can also be expressed as dy by dx is equal to f of x comma y. That is, both the standard form. That means first form of differential equation can be expressed into second standard form and vice versa. So in order to find the solutions of first order and first degree differential equations, Leibniz made many contributions in order to provide the procedure for solving first order and first degree differential equations. The first order and first degree differential equation can be solved with the help of these four methods. First method is variable separable method, second method homogeneous method, third method is linear differential equation, and last method is exact differential equation. Variable separable form is actually a method by which first order and first degree differential equation can be solved. Variable separable form: if it is possible in given differential equation to collect all the functions of x along with dx in one side and all the functions of y along with dy on the other side, then this form is said to be variable separable form. Suppose the given differential equation is dy by dx is equal to f of x comma y. If it is possible to write this differential equation in the form of function of x along with dx in one side and function of said to be variable separable form. If any equation of first order and first degree differential equation can be expressed into variable separable form, then its solution can be directly written as by simply integrating both the sides and adding the constant of integration, that is c, in any one of the side. Then by equation 2 we can write its solution when the given differential equation can be expressed into variable separable form. Suppose considering this equation, dy by dx is equal to x times 2 log x plus 1 divided by sine y plus y sine y cos y. In order to find its solution, we first try to write this equation in variable separable form, or simply separating the variables. That means we are trying to collect all the functions of x along with dx. Suppose this can be done by simply cross multiplication. X 2 log x into x plus x time into dx in one side, and write all the functions of y along with dy in another side. So this form is variable separable form, and its solution can be obtained directly by integrating both the sides and adding the constant of integration in any one of the side. So we integrated both the side, we find this equation, and after integration, sine integration of sine y is minus cos y cos y, it means simply integrating by parts, is equal to, again integration of this term can be evaluated with the help of by parts plus integration of x, that is x square by 2 plus c. So after simplification, this is the required solution. So variable separable form can be easily solved by simply integrating both the sides and adding the constant of integration into any one of the sides. Suppose this second example, we have to solve this differential equation. So in order to write into variable separable form, our target is to write all the functions of x along with dx. Here sec square x tan y dx is given. Our objective is to write all the functions of x along with dx. Here tan y is involved, so we have to remove this tan y. So first, and in the second term sec square y tan x dy, sec square x y tan x dy. So our objective is to write all the functions of dy along all the functions of y along with dy. So here tan x should be removed by simply dividing the whole equation. Therefore, this equation can be written into variable separable form by dividing the whole equation by tan y in order to remove this function of y from this term, and by tan x so that it can be a function of y along with dy. So this expression or this equation is obtained. Here all the functions of x are along with dx and all the functions of y is along with dy. So this form is variable separable form, and in order to find its solution we have to simply integrate both the sides and we have to add any constant of integration in one of the side. So integration tan x is taken as t. Therefore, sec square dx equal to dt. Simply integration of 1 over t, which is log t, that is log 10x. And similarly, this integration of this term is log 10y is equal to log c. And finally, with the help with the properties of logarithmic function, log m plus log n is equal to log m into n is equal to log c. Therefore, 10x 10y is equal to c is required solution.